Good morning, Julie, and thanks for the introduction, for the kind introduction, and nicely meeting all of you. I'm Domenico Siracusa. I'm the head of the Robust and Secure Distributed Computing Research Unit at the Bruno Kessler Foundation, which is a research center located in the north of Italy. And we mostly work on making this continuum between cloud to the edge, so from the cloud to the things, more secure, robust, and efficient. Now, I'd like to start with my presentation. You should see my screen, and that's basically the idea to talk a little bit about distributing artificial intelligence in this continuum. So, and this is the vision of the Decenter EU Korea project, a project that started in 2018, will finish in June 2021. So, I'll start directly with our focus. So we are focusing on a trend that is called edge computing. This trend, as this release, this magazine says, it's a trend that will color the software industry in the 2020s. And we believe it is a particularly important trend because it allows to overcome some of the limitations of a cloud-centric approach in which you see this on the left, data gathered from things that were deployed in the city, for instance, where it was all gathered and sent to a cloud, possibly a public cloud, where this data was, or a private cloud, where this data was elaborated for whatever scope by means of artificial intelligence methods and solutions, for instance, for people recognition, weather, whatever, forecast or whatever. The point with this solution is that it introduces latency because you're sending all the data to the cloud, so it takes time. You're using a lot of bandwidth. Imagine if you have a lot of cameras, and privacy of data has to be preserved as well. But if you start using the whole computation continuum that brings you to the edge, maybe installing some devices in edge places, you can distribute your intelligence from the cloud to the edge and reduce latency because you process things earlier, reduce bandwidth because as soon as you process, you need less, for instance, the video, but you have already processed data, and you can also ensure privacy. So we're sitting on top of this trend, but the problem is, in order to implement it, it is a matter of perspective because we stand between two figures here, which are the developer of the application, who is interested in the accuracy of its application, the completion time of the application. So how long does it take to recognize a person, to recognize a danger or whatever, and of course the user experience. And then who's managing the infrastructure? The person that is managing your smart city ICT infrastructure is interested in the number of applications it can provide to its customers if it's robust and secure. As you see, those two guys have very different perspectives, very different goals, and there is a gap between them we aim to fill with the Decenter project. This Decenter project is therefore trying to helping developers in creating cloud native applications. What do we mean by that? So starting from an AI model, which is just a model, we can support the application developer in creating an application that is composed of small services that are talking to each other in order to interact, and then they can be deployed in the AI, in the cloud to edge continuum in a dynamic way. So once we create these applications, the center helps us in operating them anywhere at any time in a seamless, efficient, and secure way. Of course, we cannot go through all of these things, but I wanted just to highlight what are the key innovations that the project is delivering. And the first one is a smarter IoT fabric. So we have to cope with a data deluge that is coming from multiple data sources. But most of all, what we want to do is to be able to read those data and have that data available directly at the edge, so close to where data is originated. And the second thing is that, of course, AI models can be quite complex, and the center is helping the AI developers in fitting complex and resource demanding models into resource constrained devices. Of course, you don't put the data center in a lamppost. And then once you have these models and you have this data, you have to orchestrate, manage the life cycle of your service. And in this sense, we're using a fog computing platform that helps us in gathering all the benefits of the cloud outside the data center, as well in the edge. We will see this later. Finally, what we're doing is we are establishing a framework based on blockchain to catalyze demand and offer for infrastructure resources. Assume you need an let's say a gateway somewhere which you don't have your own resources, you can buy them, you can rent them, or AI resources. For instance, you need a model, you can get it from the framework, from the blockchain marketplace, and get it and use it. Then you seal a smart contract, you monitor the smart contract. If it is fulfilled, it gets rewarded. How are we using this? So what are we providing? So we are maybe you have seen this picture before, but we are starting from the infrastructure and on top of this edge devices, computing nodes, and IoT devices, and we are providing our platform that is composed of many components and the center services and tools. And here is just a breakdown which shows you our fog computing platform, the SenseNact, which is our IoT broker, also Things Plus, it's another IoT broker coming from, and device manager coming from Korea. And then of course on the services, we have the iPackage, digital twin, model optimization, and more. So I won't go into the details of this because maybe it is too technical and not really rewarding now. But what we do is we have a set of use cases that sit on top of our, on our infrastructure in order to enable this digital transformation. And the first one I would like to talk about, and the one which I would like to focus on, is the smart city. So we did an installation, a pilot, and in the smart city of Trento, which is the city in which my research center is located, and there is also a partner, the municipality of Trento, involved in this project. And we have cameras, microphones, and IoT sensors, and we are using artificial intelligence to detect vehicles, pedestrians, and changing weather conditions to assess if there are potentially dangerous situations for pedestrians. The idea is that when there is a potentially dangerous situation, we are able to timely alert vehicles and pedestrians. Now, for given this service, which is a sample service, we think that the most important priority is the latency. You want to be able to alert the pedestrian right on time when if a car is approaching fast. And this is quite important, not only because this, you don't see it, but behind this this crossing, there is kind of a curve that doesn't allow that much visibility. But moreover, it is the point of pedestrians are always more and more, distracted by their phones, so they may not be really aware of what is happening. What is the center providing us is, as I say to you, is a tool for creating this application in a set of containers. And this is a vision of the fog computing platform in which we introduce this application. This orange boxes are the endpoints, so the weather sensors, the cameras, and the actuator that gives the alarm. It's a sound alarm, it's a beeping alarm, it's also lights. And these are the services, the microservices that compose the application. The application developer just started from the model, but the central platform helped them in creating this set of microservices that are gathering the information, are understanding if there is a risk, and are providing an alarm. What the infrastructure operator has only to do is to go on this operate button and say deploy, and it's automatically deployed. Before I go ahead, just one mention here. As you can see in the alarm, between the alarm and the detector and the actuator, we put a latency of 500 milliseconds. I will say something later on. So once the operator just click on that deploy, this is automatically deployed by the means of this Fog Atlas platform that has been committed to the project. And it is deployed between the cloud and the edge. These are regions, means that they can have multiple computing nodes, multiple computers. In this case, this one was just a node on the lamppost, not on the lamppost, on the crossing, sorry. And you can see this dots are the different microservices that have been deployed, and they have been, kind of one here and three here, but that's how it has been deployed by an algorithm that is running, and I will say something later on. So once you deploy the service, the camera feed is starting to be augmented with information from the AI models that recognize the cars, recognize the pedestrians, and then you have, of course, your digital twin that shows what is happening, and you have also the application response time, the actuations per day. But this is how the developer designed it. But what can developer, the infrastructure owner, can do with this platform? Well, for instance, the service KPI. So the first thing is that we deploy the application without specific quest constraints on the actuator. You remember I said it was 500 milliseconds. So we have a resource optimization policy so that if you respect constraints, you try to save edge resources. So the actuation thing was sent, microservice was sent to the cloud, and that was the latency we had. Let's assume the city manager says, okay, this is too high. What he has just to do is to go to the same platform for Gatlas and say, okay, I want to decrease my latency from 500 milliseconds to 60 milliseconds, for instance. Just click on update. And since this latency was not respecting between the edge and the cloud, the algorithm that is placed on the platform says, okay, now I must send this microservice from the edge to the cloud. And here, all the microservices have been deployed at the edge. Now, indeed, we checked again, and now our latency was reduced from 140 milliseconds to 50 milliseconds. In this way, I mean, citizens could be safer. So let me just recap quickly, and then I can close. By using these technologies, you can achieve great, using cloud-based technologies outside at the edge, you can achieve great scalability, because you can deploy hundreds of these services just with one click. And if you have to update them, it's for ease of management, it's really easy, because you just do a click, and deploy. And this is much less error prone, because if you have, for instance, to update one of these 4 guys because there is a bug, and you have to update this on 100 deploys, what do? You do this manually? No, you just say, okay, I have changed this descriptor, just update all the instances of this service. And finally, of course, performance. As you can see, if you describe what are your requirements, there are algorithms that find you the best suitable allocation for your services over your infrastructure. We have other use cases on robotic logistics to help robots in the factories and construction sites to help in identifying risks for workers, and ambient intelligence. We have a nice use case from Korea where we have a, let's say, a tool that helps people in offices and recognizes the place in which they have to go based on their identity, which is automatically recognized. We have use case videos on our website. You can see videos of all these use cases. And if you want to get in touch with us, use our website, our handler, or get in touch with me. We also have a booth at this amazing event. Thank you for listening and for the great invitation to this event.